In this lecture, we will talk about the database development lifecycle. We will first see how databases fit in the overall application infrastructure. We will look at major stages of the database development lifecycle. We will see how we can use software tools or case tools to help us design a database. We will also look at some of the industry-based practices that we can follow when we design a database. Modern applications are most likely web-based applications. They run in a distributed computing environment. Quite often, we have remote users running the application in a browser. Remote users send their data requests to servers located at a data center via either a private network or internet or a combination of both. The requests are first routed to the web front-end server. Then the web front-end server will route the requests to an appropriate application server or a mid-tier server. Eventually, the requests are sent to the back-end databases for processing. The results are returned to the users via the reverse route. So it's obvious and important. We need to have a well-designed database on the back end. A well-designed database will make our applications a lot more useful. A well-designed database will also improve the performance of our applications. The database design process can be broken into stages. Generally speaking, we start with gathering business requirements. Once the business requirements have been identified and documented, we move through three major stages of database design: conceptual, logical, and physical. Once we are done with the physical design, we will implement the design on a platform that we have selected. Most likely, we will do some prototyping and testing in a test environment before we finally roll out the design to a production environment. When we work on business requirements, we need to develop a mission statement. The mission statement lists major goals the database will accomplish. We have an example here. Once the mission statement has been established, we need to work out mission objectives. Mission objectives are the tasks the database will carry out. For example, if we are designing a bookstore database, the mission objectives might be inventory control, order processing, customer care, and so on and so forth. Throughout the development process, we need to gather information to help us design the database. There are several ways we can use to help us gather information. We can examine existing data. The existing data could reside on paper, could be in a spreadsheet, could be in some computer programs. Also, it's important that we work with our users and the management closely at each and every stage throughout the development process, interviewing is a very useful technique to help us gather the required information. There are three major stages of database design: conceptual, logical, and physical. At the conceptual database design stage, we focus only on the data requirements. We identify entities and attributes or properties about entities. Remember, entities reflect the real-world objects such as customers and orders. Then we move on to the logical database design stage. At this stage, we need to select a data model. Most likely, the data model will be the relational data model. At this stage, we also do normalization and some other fine-tuning activities. We will also work out more details about our database. Finally, we move on to the physical database design stage. At this stage, we have already selected a platform that we will implement our design on. The platform could be Oracle, could be SQL Server, or other database management systems. At this stage, we will develop additional database objects such as indexes. At this stage, we will tweak or adapt our design so that our database will work best with the platform. Generally speaking, there are two major approaches that we use when we design a database. They are top-down or bottom-up. With the top-down approach, we will first identify high-level entities. Then we will work out details about entities such as attributes belonging in an entity. Once we have entities and attributes for an entity, we will go through the fine-tuning process. We do normalization during the fine-tuning process. The other approach is bottom-up approach. With the bottom-up approach, we will first gather all the required attributes or the pieces of data that we need to track in the database. Once we have identified the required attributes, we will group attributes into entities. Then we will go through the fine-tuning process, and we will also do normalization during the fine-tuning process. Keep in mind, the database is usually part of an application development project. So when we design a database, quite often the application design is also taking place in parallel. So those two activities are commonly happening in parallel. There are a lot of software tools or case tools that we can use to help us design a database to make our job much easier. Usually, case tools provide some features that can really help us design a database. For instance, case tools can provide a data dictionary. The data dictionary will have information about the data we store in the database. In other words, the dictionary has metadata about other data. So the data dictionary is very, very useful as a reference and also as a way to enforce data standards within a company. The case tools can also help us gather business requirements. It can help us create charts, diagrams to reflect business requirements. Also, case tools can be used to create various models such as conceptual, logical, and physical models. If everyone on the team uses case tools, then we can easily standardize the work the team does. Also, we can ensure the consistency of our work. Most importantly, the case tools can easily integrate with other systems we also need to work with. For instance, the case tool can generate SQL scripts based on our design. Then we can run the SQL scripts on a platform that we have chosen to implement our design. Case tools also provide two very important features: forward engineering and reverse engineering. Forward engineering will generate the SQL scripts, the required SQL statements. Then we can just run the SQL statements to implement our design. We don't need to manually create those SQL statements. Reverse engineering is a wonderful way of documenting existing databases. What we can do is that we can plug the tool into an existing database. Then the tool will create an ERD for the existing database. So it's a very, very efficient and effective way to get the current documentation about existing databases. When we design a database, there are a lot industry-based practices that we can follow. It's very, very important that we clearly identify the scope of the database to begin with. That's the only way we can ensure the punctual delivery of the project. Also, when we design a database, it's very beneficial that we follow a development methodology. There are some common methods that we can follow. For instance, we can use either SDLC or one of the Agile approaches. Very often, we do not design a brand new database. Instead, we are modifying an existing database, or we are upgrading an existing database. Here is a checklist that we can follow. Keep in mind, we can use the reverse engineering feature provided by case tools to get the current up-to-date documentation about existing databases. Also, it's very, very important we have a migration plan in writing. In the migration plan, we want to make sure that we get all the parties involved. For instance, we may need the network group to update the IP addresses and DNS records when we migrate from the old system to the new system. We need to notify users of the planned system downtime. We also need users to do user acceptance testing once the migration is done. This concludes the lecture on the database development lifecycle.